Alright, I've got this pattern here. It's actually triangular numbers, isn't it? I've got 1, 3, 6. It's increasing by 1 more each time. So it's going up by 2, then going up by 3. And I've got the first 3 terms. So my next term, my 4th term, I'm just going to write it out. 4, 5, 6, 7, 8. So I've got my first term, my second term, my third term. My 4th term would be 10, adding on 4. My next term would be 15, adding on 5. My next term would be 21, adding on 6. My next term would be 28, if I add on 7. And my last term, I would add on 8, which would give me 36. Okay. Now, which of the following is the nth term of the sequence? Show how you decided. So, I'm just going to substitute in some numbers from the sequence and see if it works. So, let's just substitute when n equals 1. Because that's probably the easiest substitution. So I've got 1 squared minus 5, which would equal minus 4. So it can't be that one. Right? This would be 2 times 1 plus 1, which would be 3. So it can't be that one, right? This would be 2 plus 1, which is 3. And it's not. The answer, first term is 1. So that doesn't fit. So it must be n squared plus 1. Let's try that. 1 plus 1 squared plus 1 divided by 2. 1 squared plus 1 divided by 2, which is 2 divided by 2, which is 1. So that one works for the first term. If I want to just double check it, I could try a different term. Let's take the third term where my answer should be 6. I've got 3 squared plus 1 divided, so my third term, 3 squared plus 3, I'm adding the n to the n, divided by 2, which gives me 9 plus 3 divided by 2, which gives me 12 divided by 2, which gives me 6. That works for the third term. So I've got n squared plus n divided by 2. And it's because, as long as there's some working out, that really is the because. You could write something like, when I substituted, it gave the right result. So that would be the sort of answer there that I might be looking for. Question 6.